So you need to know how to solve this. We discussed how to push log base in our calculator the other day. So even if Cooper has no idea how to do the log problems, if he presses math, log base, and types in some numbers, maybe he can figure it out. What he's supposed to do is realize it's supposed to be 4 to the negative 2 equals x. I punish that negative 2 exponent and send it to the denominator, so it's 1 over 4 squared equals x. So my answer is 1 over 16. But again, these are rules of logarithms, so it's just do you remember. So 19, since they have the same base, we actually can ignore the log, the base 3, and we can just set 2x plus 18 equal to 3x. When we subtract 2x from both sides, we get 18 equals x, and we're done. Now, if you're not writing these down, that's silly of you because the semester exam study guide is a 60% grade. It is due to take the day you take the exam. So if you take the exam on a Tuesday, it's due on a Tuesday. You take the exam on a Friday, it's due on a Friday. If you turn it in late, I'm going to take off points, which is dumb because it's supposed to be an easy 100. If you think I'm not going to type in the 0, you are sorely wrong. You would not believe how many don't turn in semester exam study guides, even though I tell you the answers. It's strange. Okay, on number 20, there's a rule that says if logs have the same base, which they do, and we're adding them, we can really take the terms inside and multiply them. So if we see 2 logs with the same base and they're added, we can actually multiply the numbers. So it's log base 3 of 7x equals log base 3 of 14. But now, since they both have the same base of a 3, I can ignore that log base 3 and go straight to 7x equals 14. So x equals 2. Yay. (21) Still involving rules of logarithms. When they don't write the base, it's understood to be a 10. If you want to write it, you can. It's kind of like when we see like x plus 7, we know there's a 1 in front of that x. We just don't bother to write it. We just normally don't bother to write the 10. So it's log base 3, or log base 10 of 3 equals x minus 8, and they have the same basis, so really it's a division, so it's log base 10 of x divided by 8. So if 2 logs have the same base and they're added, we can multiply the terms inside. If 2 logs have the same base and they're subtracted, we divide. So now they have the same stuff going on, so I can go to 3 equals x over 8, so 24 equals x. I should have put more space between my work, but oh well. Because they had the log 10, this one has log 10, it's like I'm covering them up, they go away. So I have 3 equals x over 8, so 24 equals x. 22 is the hardest one, probably on the study guide for most of us, because especially if we're uncomfortable with these rules of logarithms. This one involves 3 different rules. So the first rule is that if there's a number in front, you can take it and it's really the exponent of your term. So it should be log base 5y minus log base 5 r to the 4th power plus log base 5 x squared. So first thing I did was take the numbers and make them exponents. So there was one rule of log to use. Bummer. What's sad is that using 2 other rules of logs. So since they're subtracted and they have the same base, I can combine these 2 and make it log base 5. Subtracting means division, so y over r to the 4th. And I'll just bring that guy back down. And last but not least, since these 2 have the same base, and they're both logarithms, and they're added, it's multiplying, so my final answer is log base 5. I've got that r to the 4th in the denominator. I've got x squared y in the numerator. So that one's probably the hardest one on the entire study guide, in my opinion, just because most people are uncomfortable with logs. Okay, so that's our semester exam study guide. We're still going to keep going through the answers. For my seniors, I'm going to post the key Friday.
Do we need to turn in our picture to the box?
You can. Thank you for saying words. Okay, so did you turn in all the stuff from last week, the 12-1 stuff? Funny Face isn't due until Friday, but if you already have them done, of course go ahead and turn it in. Do you have to color him? No, it's just for extra. Have you showed me your angle maze from Friday? Most have not. And then we talked about that 12-2, 12-3 test being on Google Classroom. Okay, you picked up a study guide on the way in. It is going to be a 5-point bonus for the test that's on Google Classroom. Could you have to do it? No. Are we going to briefly discuss it? That way Angel can rock this test without having to consult Google or her notes because she's just smart? Yes. Angel already understands how to graph them. She's got 1 through 6 down. She knows where to put 70 degrees. We've discussed that enough now. She also understands how to find a coterminal angle. Because we discussed, like, you do 705 minus 360, and you get 345. So all coterminal means is if I were to draw the angle 705, so I went around once, and then I went around again. When I came back around and I got to here, I was at 705, but that's the same spot as 345. And I didn't do a good job drawing that. It should be a little closer to that line of 360. I'm just proving a point really fast. We discussed that on Friday and on Monday. I feel like you're okay with this. In fact, I bet Ellie could pass a test on this without having to consult her notes. She can do this. Are there any questions about this part? So I drew that really ugly. So for instance, they might give you like 375 and ask you to find the coterminal angle. So I would just subtract 360 and get 15 degrees. And all that's saying is that this angle right here is at the same spot where 15 degrees would be, but it's also the same spot where 375 would be, because you went full around the circle once and you went back up a little more. And my pictures are just getting uglier and uglier today. If you flip to the back, you do not know how to do 10, 11, and 12. Sad day. We're really just sucking it up on preparing you for the trig world. We've not talked enough about radians to expect you to do that. But we have done the basics of how to convert from degrees to radians, because radians is like what we're going to use when we really full out do trig. So if you're wanting to, and we wrote this down Monday, but just a reminder, degrees to radians. You're wanting to add pi, so you'll multiply by pi over 180. Radians to degrees. You're wanting the pi to go away, so you divide by pi. Regardless, you're using 180 and pi, you're just trying to figure out how to put the fraction. Even if Angel gets stuck, she knows that I've said these words, and she can watch my videos on Google Classroom because she can have her phone out tomorrow too. So she's going to figure this out. Okay, so all this how to convert and how to figure out the angle measure has to deal with that right triangle trig you did of sine, cosine, tangent. It has to deal with all that. And what they all have in common is something called the unit circle. I'm going to post some stuff about it on Google Classroom. If your goal is to take a math class after me like pre-cal, I highly recommend you look at these links and figure out, I drew real ugly then, figure out this unit circle before you take this next math class. If you're wanting to be an engineer, an architect, anything that's going to be mathy, you've got to know the unit circle. You've got to know it, like off the top of your head. Okay, so there's a circle, and it's on the coordinate plane. It's centered. I drew that terribly. It would be centered. Let me lower it. Centered. Ignore the brown. The center of it would be at the origin. And it's called a unit circle. For one, a unit is 1, because everywhere on the unit circle, we have a radius of 1. Everywhere you go, no matter where you are on the unit circle, you have a radius of 1. That's why it's called the unit circle. Unit meaning 1. Okay, and you probably should be like, but I don't understand, Ms. Comden, how the crap does that have anything to do with the sine, cosine, tangent? I don't understand. Those were triangles. You draw in a circle. I don't have triangles, circles. I don't understand. So what happens is we use triangles to make the unit circle, special right triangles. But anyway, we use triangles to make the unit circle. So if you draw your triangle on your circle right now, which you don't have to, I'm just saying words. If you draw your triangle on the unit circle, or on a circle like this, a right triangle, and you put your x or your theta, whatever your missing angle is there, on the unit circle, the radius is the same thing as the hypotenuse. So if the radius is always 1, the hypotenuse is also always 1. So when we solve for our three sides, we would always get 1 for the c squared, for the c and the c squared, because the hypotenuse is always 1 on the unit circle. So it's super weird. So if the hypotenuse is always 1, we start getting really weird answers for our x and y coordinates. So what Miss Thompson's about to work is never values we would see on the unit circle, because the unit circle has really tiny values, numbers that are smaller than 1, like 1/2, square root of 2 over 2. So the ones I'm about to work, you're like, but they would never appear on the unit circle. Literally, it's like I'm showing you how to make a cake, every step up to the cake, and then we're never actually going to eat the cake, which is my bad. In my next life, I'll schedule my pregnancies back. Okay, so I'm going to work 19, 21, and 23 really fast. I'm not going to bother with the evens. You're like, how the crap are you going to work these? Okay, so you know how to graph stuff. You know 3 negative 4 means go over 3 down 4. You know this is where 3 negative 4 is. You know how to graph negative 4, 9. You know how to graph negative 3, 6. You didn't need me to teach you that. You learned that in algebra. Now all I'm going to do is draw a triangle to those points we graphed. Not only am I drawing a triangle, but it's a right triangle. And on every single one of these graphs, I'm going to put the theta, or that missing angle, really close to the origin. So I put this one here because that was closest to the origin. I put this one here because it was closest to the origin. This one here because it's closest to the origin. That's called our reference angle. You don't have to know those words. Okay, so 3, negative 4, if we're trying to figure out side lengths, we went to the right 3, then we went down 4. And they ask us in the problem to find the exact value of the 6 trig functions, which means we're going to need that third side. So we're going to need to solve for this missing side. So we're going to use our Pythagorean theorem, 3 squared plus negative 4 squared equals x squared, or c squared. And when we solve, we'll end up getting 5. Plus I know 3 4 5s is a triple. So I solve for that missing side of the triangle. And I could go do the others the same way. In fact, so I went back 4, up 9, so negative 4 squared plus 9 squared equals c squared. 16 plus 81 equals c squared. Square root of 97 equals c. I could, and every single time we're setting this up, we're always solving for the hypotenuse. Every single time. So if I set up the last one, a squared plus b squared equals c squared, I know it's going to be negative 3 squared plus 6 squared equals c squared. And one mistake Justice might make is when he squares stuff, he better make sure he gets positive numbers, because negative 3 squared is positive 9. So we solved all these problems. We solved for this missing side on the triangle, and every single time the missing side was the hypotenuse. And you're like, fun times, Ms. Compton, but you just said the unit circle always has a hypotenuse of 1. That's not a 1, that's not a 1, that's not a 1. You're right, none of these would appear on the unit circle because the hypotenuse is not 1 on any of these. But the problem says to do it, and it's trying to get us ready to deal with the unit circle. So I need to figure out this trig function, so sine, cosine, tangent, cotangent, secant, and cosecant. But now that I've solved for that third side, it's going to be easy because this side's the opposite. We know this is the hypotenuse. We know this is the adjacent. So sine is opposite over hypotenuse, so it's going to be negative 4 over 5, which means cosecant is 5 over negative 4. We know cosine is adjacent over hypotenuse, so 3 over 5, which means secant is 5 over 3. And then tangent we know is opposite over adjacent, so negative 4 over 3, which when we flip that is negative 3 over 4. So sad day, we're combining a lot of things we've learned all at once, but we can find those 6 trig functions figuring out using these coordinates, which again it says it's the terminal side, so it's like we've drawn this angle to here. Okay, so if I asked Jax if I asked him to find the sine, cosine, tangent, cosine, he could. Sine would be opposite over hypotenuse, so 9 over the square root of 97. Adjacent would be negative 4 over the square root of 97. He could keep doing this. Now that he's got all the sides set up, he knows how to find sine, cosine, and tangent. He just took a test on that. I know he can do this. He just needs to figure out how to get the triangle in order to make that happen. Okay, I said a lot of words. Are there any questions about that? Yes, there is.
So you have to also make a circle with it?
No, so and that's a good question because I did say about being circle. No. I'm saying that the reason we're doing all this is it leads to this. Again, it's like I'm showing you how to add in the flour right now, but we're never actually going to get to the cake.
Okay.
Sad day. It's really depressing. Like, so you sift the flour and now I add it and I mix and now what? Like, so what was the point in all this if we're never going to get there? But, I mean, you need it. At least you're almost there. At least we'll know how to make a cake. So we don't get to eat the cake. At least we know how to make it. Okay.
You're going to send us what we need to know for pre-cal next year.
Yes, that's our plan. But again, if you're really trying to be successful for pre-cal, you would go